Good morning. Hello. I'm audible. Anybody? Anybody say? Okay. Good morning to everyone. Behalf of Department of Botany, Periyar University Constitute College of Arts and Science, Arur, we welcome you fourth day international online seminar on national products for health diseases. I have honor to warm welcome today our special guest speaker, Dr. Gribabu Nelli, from Department of Physiology, Faculty of Medicine, University of Malaya, Malaysia. Dr. Gribabu completed his master degree and a doctorate from Sri Venkateswara University, Tirupati. He has been postdoc fellow from 2013 to 2016 in Department of Physiology, Faculty of Medicine, University of Malaya, Malaysia. His research area is mainly focused on male and female reproductive endocrinology. He published 59 research articles and 3 book chapters with a high impact factor in reputed journals. He received more than 2 crore research fund from various funding agencies in Malaysia. Now I would like to say thank you, Dr. Gribabu, for accepting my invitation for this wonderful seminar. Now I request Dr. Gribabu to proceed your valuable talk. Just I will transfer words to you. Thank you. Hello, Dr. Nelly. Hello.
Hello, can I start my presentation? Hello, can you see me?
Doctor, you can start your presentation.
Can you hear me?
Yeah, here.
Okay. Can you see my presentation?
Yeah, yes.
Okay, thank you.
Doctor, you allow all the participants. You can see the all the participant list.
Yeah, okay.
Admit all. Then mute it. Okay.
Okay.
Okay. Proceed. Okay, start.
Okay. Good morning, everyone. My name is Giribabu Nelli. I am from India. I am basically from Andhra Pradesh. So I did my PhD in SV University, Tirupati. Then I moved to Visakhapatnam. Then I moved to in Malaysia. I did my postdoc fellow here 3 years. Then I got a promotion like a senior lecturer. So last years I'm working as a senior lecturer. My research area mainly on the male and reproductive complication, and also working on some of the natural product, working on the diabetes complication also. So today I would like to present mostly on the male reproductive complication and also what is the molecular mechanism. Is there any possibility to reduce the male infertility? So today I will discuss. So my topic is molecular mechanisms of male infertility and significant role of natural product. So coming to Coming to the infertility, what is infertility? Mostly we know infertility like to achieve unsuccessful pregnancy within 1 year with unprotecting intercourse. So means without using any like a sexual what you call like unprotected sex means like by using like contraceptive methods. Within 1 year, if the couples are not getting any pregnancy, we consider as the infertility. So in the worldwide, nearly 30 percentage contributed from the males, 30% contributed from the females, and remaining 20 percentage contributed from both male and female, unexpected nearly 20 percentage. Today, I mainly focus on the male reproductive complication. So I did my work on the female reproductive complication also. Very difficult to compare both also. Coming to the male reproductive complication or male reproductive infertility, why mostly nearly 30% of males getting infertility? So many reasons is there. Generally, congenital problems like some people like have congenital abnormalities. For example, cryptorchidism. Some babies are born with a cryptorchidism means their testis mostly generally we know the testis present in the scrotum. It is like when the baby born, when baby ready to born, the testis coming from the abdominal cavity to the testicular cavity. Some people, some babies, they have like in the even the baby born also, the test is present on the abdominal cavity. That condition we call as a cryptorchidism. So this condition, when the baby's test is present in the abdominal cavity, because of the high temperature, testis cannot survive. Spermatogenesis was stopped. So mostly this is also cause infertility. Not only the cryptorchidism, so many congenital abnormalities is there. It causes the 1 minute, sorry. Hello. Admit, I don't know how, how to admit. Okay. 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 Ah, yeah, I'm using. No, I wasn't using any earphone. Sorry. I'm not using. Okay. I will stop my earphone. Okay. 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 Sorry. I'm sorry, friends. Okay. So many complications coming. So many factors interfering causes the male infertility. Coming for the like a varicocele means you know that one like mostly the and the testis vein varicocele vein it will be bulging. Once the bulging in the scrotum too much of water will be accumulated, so the intraocular pressure was intratesticular pressure was increased, so that sperm count and motility also decreased. This is also one of the factors for increasing the male infertility. For the STD, sexual transmitted disease, so many like syphilis, gonorrhea, and AIDS, so many sexual complications also. And they are also causing the infertility. Sorry, something like interfering. So endocrine factors. So many endocrine factors because in the day-to-day life, so many like we are using so many like for example, mostly the farmers using fertilizers, pesticides, and fungicides. Also, for example, we are using everyday cell phone and computers. These are all factors may be affecting the reducing the testosterone levels. Once the testosterone levels decrease in the male, it causes the infertility because the testosterone is important only not only for the sexual complication and also secondary sexual complication also depend upon the testosterone. So once the testosterone levels is decreased, it causes the male infertility. Seminal abnormality. We know generally like in the males nearly 2.5 ml of semen was secreted. It is less than to 2.5. Some people have like a less semen semen value. So like some if it indicates some either maybe the problem in the seminal weight scale, maybe there or maybe it indicates the problem in the prostate gland. So once the semen is very less, so means there is no very less nutrients. It is also causes the male infertility. Coming for the sexual dysfunction, okay, sperm or like anti-sperm antibodies. Some of the humans normally the sperm is without like a clumping, so the sperm easily move after sexual intercourse. So the sperm is deposited in the vagina, and it is like a to the cervix. It will easily move. But unfortunately, some males they have like a auto antibodies. So that what was happen? So the sperm will be accumulation will be happen. Clumping will happen. So they want to attach each other like a head to head, head to tail, head to midpiece. So the sperm cannot move through the male reproductive tract. This is also one of the causes for the male infertility. Some unexpected infertility reasons also there. Some seminal plasma abnormalities also there. So these are all the factors may are mostly causing male infertility. So now we are discussing. Sorry. Okay. Now we are discussing nearly 30% males are contributing the infertility. So, but in the worldwide, if you see the like a globally infertility, even not only 30% in Asian countries, nearly 37% of abnormal male infertility caused because of the males. So nearly 40% of infertility contributed from the males in Australia. Coming to the African countries, nearly 43% of males contributing the male infertility, and mostly like a Middle East people, nearly 60 to 70 people, males contributing the infertility. We already discussed infertility is like a complex process. It is comes more. It may be problem with the male. It may be problem in the female. So I'm telling here here nearly 60 to some coming to the Middle East people, nearest Middle East people, 60 to 70 percentage of infertility contributing from the males. Okay. So even though even American countries and Latin American countries also the contributing the like a male factors nearly 50 to 50%. So come now I'm coming for the India. In 1950, nearly each couple have a six babies coming for yearly wise. So the babies number was decreasing. So now if you observe in the 2080s, each couple have a 2.2 babies only, 2.2, 2.1. So what is the reason? We already know India too much of changes from the 1950 to 2018. So what are the changes? We know one is the urbanization. Other one is lifestyle factors also increasing. Other one is like a past life. Like if you're talking about like previously in 1950, we don't know KFC, we don't know laptop, we don't know cell phone. Now putting like increasing. So all these things will be lifestyle factors will be increasing the male infertility. Now in 2018, nowadays in India, nearly each couple have a 2 to 2.1 only like each they have a babies means it indicate the fertility rate decreasing day to day life. So if you observe the third figure in the mostly like some of the states they have less than 2 to 2.1. Maharashtra nearly now the two babies each couple, and Karnataka two babies each couple. Coming to the Andhra Pradesh 1.8, Tamil Nadu 1.7, and finally Kerala also 1.7. So it indicates. So what we need to discuss? So from the whole thing, we need to understand one thing because of the urbanization. So because of the lifestyle factor changing in the lifestyle factor. So day-to-day life and also the economic problem now the children's and also the ladies and females also working each other to the working both of them are working. So these are all complication causes the infertility. So so that is the reason in India nowadays we know the India one of the top country in the world where like the highest population. But when you're talking about infertility rate also increasing in India. Okay.
Okay.
Okay. What are the factors maybe rising infertility in India? So many factors we already discussed. Lifestyle factors, not only lifestyle factor, now smoking. Smoking also causes the infertility in the males, and alcohol and lifestyle factor we already discussed. So many medical reasons, so many like because of the poor people and also more population, so many medical problem comes. So we want to any small problems also we like to take more medication. Also, in India, most of the people, according to study, in India, most of the people they taking too much of contraceptives, both when compared to the male and female. So this is also one of the reason for the increasing the male infertility. And also nowadays, nowadays, so like not only these factors, like stress also increasing. So we already know, because of the so many complication, like a fast culture. So sorry, yes, okay. Stress also increasing. This is also one of the reason for increasing the infertility in India. The main thing today I want to focus on diabetes mellitus because in India, the second largest country in worldwide. So is there any possibility to diabetes causing the infertility? Yes, diabetes also causing infertility. So because now we already discussed India, the top one of the largest country. Sorry, just disturbing. Okay, they're causing the infertility. So the diabetes also one of the factors for increasing the infertility in the India. So how it will causes the infertility? How it causes the infertility in the males? So before going to the like a molecular mechanism, just I want to briefly explain what is diabetes. I think mostly everyone knows diabetes is a chronic metabolic disorder due to the hyperglycemia. So hyperglycemia means increase the blood sugar levels. We know mostly the human beings, the fasting blood glucose levels 90 to 95 to up to the 100. So some people they were above 125, that was considered as a diabetes due to the two things. One is the insulin secretion was maybe less, other one insulin resistance was maybe increased. So generally, before going to the molecular mechanism, just I want to tell like a physiology. So once the blood glucose levels was increased, what was happen? The pancreas release the insulin. So insulin can convert the glucose into the glycogen. So the blood sugar levels was decreased. Sometimes because of the diabetes, so blood sugar levels was normal condition. Once the blood glucose level is low, pancreas can secrete the glucagon, so the glucagon can convert into the glycogen to glucose, so the glucose will be released into the blood. This is the normal phenomena. Coming to the diabetes, once the so what why the diabetes comes when so many reasons is there. We cannot tell like what is the reasons. So many common reasons is there. So now I want to tell once the diabetes come, pancreas cannot secrete the insulin, especially in the type 1 diabetes. We can see, we can call type 1 diabetes also called as a juvenile diabetes. Mostly we can see in the babies. Once the diabetes come on the babies, that one mostly it can consider the type 1 diabetes. So the type 1 diabetes, the pancreas cannot secrete any insulin. So that if there is no insulin, what was happening? There is no conversion of glucose into the glycogen. So the blood sugar levels was increased very highly. Blood sugar levels was increased very highly. So coming to the type 2 diabetes, in type 2 diabetes, the insulin secretion was less, but unfortunately the cells have a resistance. So the insulin resistance was increased, so that the insulin was not affecting properly, so that glucose cannot converted into the glycogen. So finally, blood sugar levels was increased. These are the basic things. So nearly 120 million people are affected worldwide. According to 2017 statistics, 422 million people affected by the diabetes. Nearly 1.5 million people affected every year. The death rate was 1.5 million people worldwide. Coming to the India, India is one of the second highest number of diabetic patients. Nearly 75 million people affected by the diabetes. When compared to the China is one of the largest country. When compared to the China, India is the second largest country. So nearly 75 people affected by the diabetes. So we need to, now we are discussing two factors. One is infertility, one is the diabetes. So we can tell, like in nowadays, the diabetes, the infertility was increasing. The reason also is because of the diabetes rate also increasing. So I want to tell that point only. Okay. Okay. So coming to the diabetes, what was happen once the diabetes comes? Once the blood sugar levels was increased, it causes so many complications like a micro and macrovascular complications like a diabetic cardiomyopathy. Once the problems comes in the heart, that is called the cardiomyopathy, diabetic foot, diabetic nephropathy, and renal blood flow also decreasing, diabetic encephalopathy, diabetic retinopathy, and diabetic stroke also coma. Finally, it will be the patient went to the coma also. Not only this complication, diabetic patient also have a possibility to get the problem with reproduction. Previously, like most of the researchers, they focus on the diabetic retinopathy, nephropathy, and diabetic like a foot. But nowadays, most of the researchers are focusing on the diabetic infertility. So means they have a chances once the diabetes was increased, have a chances to get infertility. How it was getting the infertility? Next slide I can explain. I try to explain. So once the diabetes was increasing, not only like other complication, it is also causes the male infertility. Not only male, it causes the infertility in females also. So today I want to focus on the male infertility. So how the diabetes causing the male infertility? So we already discussed. So because of the so many factors, so drugs, smoking, and also cancer, and also so many factors influence effect on the causes the problem on the infertility. Okay, coming to the diabetes also one of the main factors that causes the infertility. How it was causes the infertility? So in our body, basically in our body, the sperm is like they have more polyunsaturated fatty acid, and also they have a more susceptible to oxidative stress. Any small oxidative stress also increase also, the sperm can easily damage. Small example. For example, like lorry drivers and taxi drivers, mostly like even the bus drivers also, if you visit like any infertility clinic, they will be most of the complications come from the like lorry drivers, taxi drivers. Do you know what is the reason? So mostly because of the ones the testes are exposed to overheat, oxidative stress is produced. So once the oxidative stress is produced, sperm already we already discussed, the sperm has a polyunsaturated fatty acid, more unsaturated fatty acids, so it can easily damage the sperm. Once the sperm was damaged, infertility comes. Even small other thing, even some athletics, some people wear like a very like a what you call like a very tight underwears also. That is also one of the causes of causing the infertility, because once the tight underwears also causes the very heat. Once the heat was produced, the sperm was very easily damaged. Once the sperm was damaged, the infertility comes. So these are the all lifestyle, because just my aim is to explain day-to-day life we are what we doing. So we unknowingly we are doing so many things. So just my aim to explain in future, you can explain to your children, even your students also. Just these are the factors. So the oxidative stress was increased. So because of the hyperglycemia also, oxidative stress was increased. Because of the lifestyle factors also, the oxidative stress was increased. The mostly we know the oxidative stress markers we can measure with measure with like reactive oxygen species, can measure with the like liquid peroxidation. Mostly research knows. Okay, 1 minute.
Okay, okay. Mute all, mute all.
Okay, 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 okay. Thank you. Okay, so once the oxidative stress was increased, so what was happening in our body? So many molecular pathways is there. Now we move to the molecular pathway. Before going to the molecular pathway, just I try to explain like a basic phenomena. So once the oxidative stress was increased in our body, they have like some of the antioxidant enzymes. So we know the antioxidant enzymes, most of the researchers knows, like soap oxidase, dismutase, catalase, and glutathione peroxidase, vitamin C, so many antioxidant enzymes is there. So that is will protecting the from the oxidative stress. So once the oxidative stress was increased, it lead to the inflammation also. So inflammation, once the inflammation was increased, finally the sperm can damage. Sperm DNA can damage. Once the sperm DNA can damage, so the defected sperm, once the fertilized with the female ovum, so the next generation also causes the problem. These are all the complication comes from the diabetes. So now I try to explain like a molecular mechanism. So coming for the like a oxidative stress. Once the oxidative stress was increased, so mostly we can measure the oxidative stress. So many methods is there, like a lipid peroxidase, and some people like a for lipid peroxidase. So many methods is there, malonaldehyde. Okay. So now
Uh,
once the oxidative anything, once the oxidative stress was increased, so in our body, NRF2 and KEAP1 metabolic catabolic gene, NRF2 and KEAP genes is there. It is always associated with each other. Once the stress was increased, once the because of hyperglycemia, NRF was dissociated. Once the NRF was dissociated, sorry, just I want to explain before. Once I move to the my work, just very difficult to understand. That's why I try to explain like some of the molecular pathway. And if you knows, maybe just recollect your knowledge. So I hope most of the researchers knows. So once the NRF2 was like, once the NRF2 was translocated in the nucleus, it can stimulate the production of the antioxidant enzymes like SOD, catalase. So many antioxidant enzymes are protected. So once the antioxidant enzymes are protected, what is the main use? So it can protecting the sperm from the oxidative stress. Okay, it was protecting from the oxidative stress. Coming for the other thing, so inflammation. Once the oxidative stress was increased, sorry, there's something. Okay, once oxidative stress was increased, it is also causes the inflammation. Generally, inflammation means mostly we have experience. So inflammation. Once the inflammation was increased, so what was happening in the two in other pathways there NFKB IKKB pathway it will be stimulating. So here also same thing like NRF2 and IKKB. So NRF2 NFKB was dissociated from the IKKB. Once in the cell cytosolic fraction, NFKB and IKKB once associated each other, no problem. Once the dissociation was happened, the NFKB translocated in the nucleus. Once the translocated in the nucleus, it will be stimulate or trigger the other inflammatory markers like TNF alpha, interleukin 1B, interleukin 6. So that what was happened? Too much of inflammation was increasing. Once the inflammation too much was increased, sperm can easily damage. This is the thing. So our aim is here, they need to decrease inflammation. So once the inflammation was decreasing, the health, the mostly the sperm can easily protecting. Okay. Other thing is apoptosis. Once the inflammation was increased, once the RYS was increased, so it also causes the apoptosis. Generally, we call it as a cell death. We know. So these are the pathways. So basically, just once I move from the molecular pathway, you can easily understand. So other thing, not only this molecular pathway, what was happened to the steroid hormones? Once the oxidative stress was increased, once maybe like other complications was like inflammation and was increased, mostly mostly
Mute all.
I'm doing so.
Mute all.
Okay. So once the oxidative stress was increased, what was happened? Mostly it affect on the testis. You know, if you're going for like a histopathology, like a pathology, so the testis have a seminiferous tubule. The seminiferous tubule, middle of the seminiferous tubule, the leading cells is there. The leading cells secrete the testosterone. So once this complication stress was increased, what was happened? It affect on the leading cell. Once the leading cells were affected, the testosterone levels was decreased. The testosterone levels was decreased. So if you know like a real like a negative feedback mechanism, so from the hypothalamus, gonadotropic releasing hormone was secreted. It was effect on the anterior pituitary. Anterior pituitary is secreting FSH and LH, so it affect on the testis. The testis can release the testosterone. So once maybe the because of the oxidative stress, because of the inflammation, so the testosterone levels was decreased. So once the testosterone levels was decreased, it causes the negative feedback mechanism, so that FSH and LH also increased. Once like a testosterone levels decrease, once FSH and LH levels are increased, so it causes the problems in the spermatogenesis also. Now, what is the meaning of spermatogenesis? So production of this sperm from the primary spermatogonia. So mostly nearly human beings 70 to 74 days was taken. So this once the testosterone levels was decreased, so the spermatogonia, so the spermatogenesis process also damaged. So we can see so coming from the spermatogonia to sperm, so many like a cycles was happen. So once the testosterone levels was decreased, it affect on the spermatogenesis. So once the spermatogenesis was decreased, so what was happened? Eventually the sperm count was decreased. The sperm count was decreased. Male have possibility to get more possibility to get infertility. Okay, coming for the things like it. So our goal is now two. One is reduce the oxidate. Sorry, one is the reduce the diabetes mellitus. Other one is reduce the infertility. So how? Both like coming for the diabetes in the market, so many drugs are available like sulfonylureas, like gliclazide, glibenclamide, metformin, and also now alpha glucosidase, and also nowadays the drugs are available like recent like DP4 inhibitors and GLP-1 activators. So many drugs are available, but it cannot increase the it cannot increase the it cannot decrease the infertility. So, and also once using like a diabetic drugs, so many years, it is also causes the side effects. And also, so many infertility drugs are available. For example, testosterone. Once you give the anabolic steroids like a testosterone, so it is also possible to reduce the infertility. But if you give like a more testosterone, it have a possible to get like a cardiovascular diseases. And marketly so many aromatase inhibitors also available, gonadotropic releasing hormone stimulators also available. But finally, the male infertility drugs can reduce the male infertility. Diabetic drugs only reduce the diabetes. But my goal is any drugs in the market in the world, any drugs is availability there, both reduce the hyperglycemia and also reduce the infertility. So I'm screening for the so many medicinal plants. So so many medicinal plant in day to day life I'm screening. So today I would like to present some of the medicinal plants previously done in some India, some in Malaysia. So what is the my aim is goal is because of the so many medicines are available like synthetic drugs that causes the side effects, and also the steroidogenic coming for the infertility, available drugs also causes side effects. So my aim is safe drugs without causing any side effects, without causing any problem for the health. So my aim is from the find out the drugs from the natural product. Why? What is the reason we need to find out the product drugs from the natural product? If you went for the history, so many history wonder drugs, for example, insulin also coming from the natural products, like malaria drugs, quinine, and also if you're talking about metformin, diabetes drug, it is also came from first when we isolate from the medicinal plant. then it was synthesized. Then now the new generation people, we know only it is like a synthetic drug. But the first time when they were discovered, like they are also from the they came from the medicinal plant or medicinal like algae and fungi. So now I like to find out some of the like screening some of the medicinal plant. Sometimes maybe once the working like a very like the drugs are working both like anti-diabetic activity and decreasing infertility. So I move up to the molecular work. Today I would like to present some of the medicinal plant. Going for the like a Garcinia mangostina. I think mostly the mostly like a Chennai people knows because uh, when I was working in Chennai, just I took this fruit from the Chennai market. So then I did my work in Andhra Pradesh, Visakhapatnam, Andhra University. So what is the reason? Basically, when I go for any medicinal plant, I want to check for the traditional uses. Then also, then what is the use? You know, mostly in the Chennai people, Tamil Nadu people knows. So because this plant mostly available in South India only, mostly in Tamil Nadu and Kerala and Karnataka. If you're going for North India, this plant is not available. Malaysia mostly like this Garcinia mangosteen available. We can see in Malaysia. So what is the traditional use? Mostly, if you talk about maybe like a traditional uses, mostly lorry drivers and also other people, they feel like it was reducing the stress and it reducing the some of the heat. So it means indirectly we can tell it reducing the stress, it reducing the oxidative stress. So when I go for the checking for the like a literature, so it reducing the oxidative stress and it reducing the like some of the inflammation. Then I move to the animal work. So today my goal is the, so coming for the my sorry, so my object was the study. So this in the study when I did in India, just I do like without molecular work, just I did only some of the basic parameters. I think most of the people knows what is the basic parameters in the reproduction. So I induced the diabetes model. So with the streptozotocin and nicotinamide, streptozotocin is a synthetic drug. Sorry, most of the like the participant like notification coming, it was disturbing me. So just I cannot concentrate. Don't misunderstand. So okay. Okay, streptozotocin is a synthetic drug. It can damage the pancreatic beta cells. We know the pancreas, alpha and beta and delta cells is there. So it will be damage the pancreatic beta cells. Pancreatic beta cells was secreting the insulin. Once the insulin was decreasing, what was happened? The glucose cannot convert into the glycogen. So it comes like a diabetic model. So why I give the nicotinamide? Nicotinamide is protecting the damaging of the pancreatic beta cells. So if partial protection is there, so my aim is I want to make a type 2 diabetes. So once the type, because what is the reason I make the type 2 diabetes also? One thing, the worldwide nearly 90 percentage of like who have a diabetes, from the diabetes people, 90 percentage of people have a type 2 diabetes, only 10 percentage people have a type 1 diabetes. So because of the like a more population, because of the ratio, so I like to work on the type 2 diabetes. So that nicotinamide protecting the damage of the pancreatic beta cells. So means the partial damage was happened. So that the blood glucose levels also moderately increasing, not highly increased. So after 3 days I check like a blood glucose levels. So then I'm making like a diabetes group, normal control diabetes, and like a low dose and high dose of alpha mangosteen. So this alpha mangosteen isolated from the Garcinia mangostina. This is like one of the active compounds. So active compound I given orally for 28 days. After 28 days, I check some sperm parameters and also the antioxidant. Yes, this is the alpha mangosteen like a mass structure. So what was happened? Going for the results. So when I give like a diabetes, when I give this plant to the animals like rats, so diabetes when you check like a blood glucose levels in the diabetic, that's very, very high. So when I give like a 55 days, sorry, not for 21, 28 days, I give 55 days. So blood glucose levels was decreased. So once the blood glucose levels was decreased, what was happening? So all complication was reversed. When I check like and body weights also decreased in the diabetes. We know the diabetes mostly the protein wasting was happen. So protein wasting was happen means what is the reason? Once the diabetes was comes, the body cannot utilize the glucose. Once the blood glucose cannot utilize, the body needs some energy. So what was happen? So from the proteins like from the muscle, it mostly utilize the body so that even the rats in human beings also, if you see the body weight, mostly the people reduce the body weight. Protein wasting was happen. Even also we can observe in the diabetic rats also. So the final body weight of the diabetic rats was decreased. But when we give the medicinal plant, it was increased. So other reproductive organs also okay, but the testis and epididymis was problem was happening in the diabetic rats. It was increased in the diabetes rats given with the alpha mangosteen. So coming for the sperm parameters, mostly who working on the male reproduction, they have a experience, but I try to explain with the unknown people also. So the sperm count generally like human beings like mostly 15 to 20 to 200 million male sperm was produced. Even some people have a 15 less than 15 million, that is called agiospermia. Some people have about 200 millions also. So some people don't have any sperm, that is called sorry, below 15 million per ml we call it the oligospermia. Some people have a less sperm no sperm to the that is called agiospermia. That is, sorry, just only for the wording. So coming for my basic basic reproductive work. So the sperm count also decreased in the diabetic rats, and motility. Mostly the motility, how they do generally when in the mice or rat. In the human beings, generally we want once the sperm coming out, we can easily measure. But coming for the rat and mice, they want to take the carda epididymis. What is the reason carda epididymis? Why don't you take from the testis? The testis have a immortal sperm, but only the motile sperm, only the motile sperm we can observe in the epididymis only. So that when we sacrifice the rat or mice, we want to take the carda epididymis only. We don't want to take the sperm from the testis. Just you young researchers, just you remember, the sperm was taken from the carda epididymis because the carda epididymis only the sperm motile. So we have one doubt. Maybe how the without sperm motile, how the sperm moving from the testis to epididymis? Maybe it's like a some logical question. So how means maybe anybody if you think logically, the seminiferous tube will have a like a smooth muscle contraction. A smooth muscle contraction, so the sperm can move from the epididymis to the testis to epididymis. Okay, now now we want to squeeze the epididymis, then we want to take immediately the sperm motility, because the sperm motility will can decrease if you increase the time. So when we want to take the sperm motility, so the progressive sperm motility only we want to count. So what is the reason the progressive sperm motility we want to count, non-progressive motility and immortal sperms also there? We want to focus on the progressive motile sperm. Reason we know, once like a sexual intercourse was happen, so what was happened? The sperm was deposited on the vagina, then it is moved to the cervix and it needs to reach to the fallopian tubules. Means forward motile sperms only can reach the fallopian tubule, and the fallopian tubule ampulla, the fertilization was happening. It is well-known process. So if maybe the reverse was happen, so what was happen? There is no use. So we want to concentrate on the progressive motile sperm. So in the diabetic rat, it was decreased, and viability also sperms also. Generally, it is a simple technique. Mostly who working on the cell culture like a trypan blue and eosin also there. So the trypan blue, we want to check with the trypan blue 1% trypan blue. This is the very simple things. So what is trypan blue? Basically, we know plasma membrane have a spermatozoa have plasma membrane. Plasma membrane who have the live sperms cannot allow the staining to the plasma membrane. If the dead sperms is there, the dead sperm plasma membrane can allow the staining like a trypan blue or anything like a trypan blue. They can easily allow the plasma membrane. So we can easily find out with the sperm viability. So if the blue color sperm is there, that is the dead sperm. Like a light color sperm is there, that is called like a that one we call as a viable sperm. So we can easily measure the HOS oil coil sperm. This is also another like a hypoosmotic solution is there. So mostly like some mostly like a sperm can coil the tail. So next picture I can show how the tail was coiled. So once the tail was coiled, that is like a good sperm. Some sperms cannot tail was coiled. That is like some damaged sperm. Some abnormal sperms. So mostly in the human beings, most of the human beings we have is a 4% abnormal sperms is there. It's common. Mostly we feel like I am very healthy, so I don't have any abnormal sperm. So impossible. Every male have the possibility to get 4% of abnormal sperm. So above 4% of abnormal sperm we call as a tetragospermia. Some people they have a more abnormal sperm. So once the abnormal sperm is more, what was happening? So the fettling capacity was decreasing to the ovum. Once the decreasing, unfortunately, the abnormal sperm was fertilizing to the ovum also. The progeny next generation also coming with some of the complication. So mostly when they're going for the in vitro IVF clinics, mostly they want to choose which one is a very healthy sperm. Then only they want to inject the ovum. This is the normal phenomena. So we in diabetic rats, I observe like in the picture you can see like so many abnormal sperms. So head abnormalities and tail abnormalities. Generally, the rat sperm, not like a human sperm. Now I'm talking about rat sperm, hook-like shape. But unfortunately, like because of the hyperglycemia, so we can see like a pin shape, like a rod shape. We can see the different abnormalities. Luckily, when I give like a alpha mangosteen, it was decreased. So this is my the basic like work when I did in India. So coming to the 3 beta and 17 beta, what are the 3 beta and 17 beta enzymes? No, the testosterone produced from the leading cells. The testosterone produced from the leading cells, but the precursor is there. Something need to production is needed. So the cholesterol is the precursor. From the cholesterol only the testosterone was formed. So from the cholesterol, so many enzymes, so many pathways is there. Testosterone can cholesterol convert into the procainolin, pregnenolone can convert dehydrotestosterone. So many things is there. I don't like to discuss because so in the steroidogenic pathway, so that process we call as a from the production of the testosterone from the cholesterol, that one called as a steroidogenesis. In the steroidogenesis process, 3 beta and 17 beta enzymes was participating. So when checking with the like a biochemically, 3 beta and 17 beta also decreased in the diabetes. Luckily, like when I give the plant extract alpha mangosteen, it was significantly increased. So my aim is whether it decrease the oxidative stress or not. So because like traditionally this plant was very useful for the reducing the stress, reducing the heat. So that is the reason my aim whether the oxidative stress was increased or not. Yes, it was increased because we know the oxidative stress mostly marker is main marker is lipid oxidation. The malonyl product was decreased when I give the alpha mangosteen. So eventually, what was happened? So once the lipid oxidation was decreased, antioxidant changes was also increased in the testis of the diabetic rat. Even if in the epidermis also I did the same thing. So when we see histopathology, so when in the testis of the diabetic rat less sperm one you can observe. So when I give the treatment, so that the sperm number was increased. So okay, coming for the next plant. Mostly like now mostly like you are mostly the botany people, you know this plant may be Colophrytum borvillineum. So we generally we call like a safford muesli. So this plant traditionally used from Ayurvedic time. From the Ayurvedic time onwards, the people was using this medicinal plant Previously, it was we can find in the like a forest area, deep forest. Nowadays, this plant is very traditionally very useful, so that most of the farmers cultivating. Now we can see like a we can see even though Madhya Pradesh, like Uttar Pradesh, and even like we can see in Maharashtra. Even we can find out in Flipkart also this plant extract. Even you can like a roots also we can find out like a Flipkart also. So so because this plant is very traditionally used, basically from the Ayurvedic time onwards, maybe the people are using. So so many health benefits is there. So coming, my aim is, so how was it was like a, useful for the reproduction, how it was useful for the diabetes, reducing the diabetes complication. So this plant also, when I check like a sperm, I don't want to explain like a sperm parameters also. When I check like a sperm, abnormal sperms also higher in the diabetic rat. The abnormal sperms was decreased. So when I see like a abnormal sperms here, the diabetic rat, so many abnormal sperms is there. Eventually, when I give the chlorophytum borbidinum, finally what was happening, the abnormal sperms also decreasing. So focus on the oxidative stress. So I can see here the sperm. This plant I did only sperm only. Like just I concentration on the sperm only. So because I took like many rats, so then I extract the sperm from the rats. So the hydrogen peroxide also higher, and nitric oxide also very high. Lipid peroxidation also very higher in the diabetic rats, significantly decreased. And we can see from the, this is the epidermis histopathology. We can see here in the picture, we can see less sperms was observed in the lumen of the epidermis. When we give this plant extract, it was significantly increased in the chlorophytum botulinum administered mice rat. So another one is Sonora diffuser. So mostly like America, and also like USA and Mexico, and that countries this plant is available. Even India, some areas also this plant is available. So what is the reason this plant was taken? Also same thing. This is also very useful for the increase the sexual drive, sexual interest. Additionally, it was using for the increasing the sexual drive, sexual interest, so that it was also taken. So what is the reason sexual drive increasing is they have a chances to increasing the testosterone levels. Once the testosterone levels was increased, so the sexual drive was increased. So my aim is how it was decreasing the sexual, sorry, increasing the sexual drive. So the same thing I did my some of the molecular work. Say, once again I induced the streptococcus in my model. So after 3 days, maybe I checked like a fasting blood glucose levels. Once the blood glucose levels more than 12.5 mg per dl, considered as a diabetic, then I separated into the four groups. Then I give this plant extract orally for 28 days. Then extract the sperm and testis. Then I check the remaining molecular pathway. Okay, coming for the by basic parameter, metabolic parameters. So I did like in this plant some basic parameters also, because we already know once diabetes comes, the body weight was decreasing. And polydipsia and polyphagia means, polydipsia means they want to take high water levels. That is the reason diabetic human beings, they want to take more water. That is called like a polydipsia. And even though the diabetic people, they want to eat more, they want to eat more, that condition we call polyphagia. We mostly we know. So even though even rats also we can observe this phenomena, high that like high water intake and also food intake, and also fasting blood glucose levels very high, and vegetative the tolerance also clearance was very less in the diabetic rats. And like TT also we observe the same, like insulin clearance also very less. So from this graph we can understand Sonora diffuser very useful for controlling the metabolic parameters in the diabetic rats. So now our aim is how it was decreasing, how it is useful for the male infertility. So if you have some idea on the male reproduction, this is the testis. The testis, we can see this is the seminiferous tubule. The seminiferous tubule we can see. So between the cells we call as leading cells. Previously I told leading cells secrete the testosterone hormone. Here you can see like the star and SHBC, sex hormone binding globulin also like a steroidogenic pathway it is participating. So the star and SHB, star and SHBG enzymes also participating in the steroidogenic, means it will means like what is the meaning? So it was useful for the production of the testosterone. So that is the reason when I observing like a star protein, mostly it is expressed in the leading cells. In the more star proteins was expressed in the normal control. When I see like a diabetic rats, I less. Sorry, just 1 minute. Okay, now I can see like a less color. So mostly, I think most young researchers knows the brown color indicate this the whole figure shows the immunohistochemistry. Sorry, just I need to explain like an unknown people also. This whole figure uh, shows the immunohistochemistry. So immunohistochemistry basically this is the one of the techniques. So many molecular techniques is there. So we know the protein like a protein expression we can find out with like Western blot and also ELISA, and also we can do like immunofluorescence. So many techniques is there. So I need to prove some of the molecular pathway like immunohistochemistry, immunofluorescent, and also some of the Western blot I did. So just I like to show my molecular work. So coming to the star protein and SHBG, these mostly they participate in the steroidogenesis pathway. So the steroidogenic pathway, we can see like a leading cells, they have a more brown color. Brown color indicate the more protein. More protein means the star proteins more in normal control. When I see the diabetic patient, diabetic rats, it was decreased. And I give like a plant extract, it even is significantly increased. SHBG also same pattern was happened. The diabetic rat was very less. Normal control, the brown color we can see more. It indicates SHBG more in the diabetic, sorry, normal control, right? When I give like the turnover diffuser, what was happened? Though eventually the SHBG levels was increased. I mean, for this figure shows the immunofluorescent. So immunohistochemistry and immunofluorescent basically the same principle, nothing there. So basically, Western blot we want to tell like protein expression. Immunisto and immunofluorescent want to show the protein distribution.
Huh?
Wait, sorry. Protein distribution means where it was distributed.
Oh.
Sorry. Where it distributes. Suppose some proteins are expressed in epithelial cells, some cells are some proteins are expressed in the nucleus. So our aim is it was where it is expressed, the protein where it distributed. So we can see here like in this figure also we can see like a protein distribution. So like a 3 beta and a 17 beta. Can you see? Okay, 3 beta and 17 beta. I can see like a immunofluorescent. Immunofluorescent also one of the technique for the it can tell us the protein distribution. So if you see like a normal control, the green color indicate like a protein. So the green color we can see normal control more. So the like a green like a flush like. I see the diabetic less green. I see means the less like a 3 beta and this was there. When I give the low dose and high dose of this plant extract, eventually it was increased the expression levels. You see, I think hope everyone can see. Then coming to the 17 beta 17 beta HSD. So we can see the red color. So the red color was higher in the normal control. It was decreased in the diabetic rate, whereas in the low dose and high dose, it eventually it was increased. So this is the like immunofluorescent. So my aim is I want to do like a different molecular work, like a different. So like okay, just I want to explain how it was happen for it is useful for the young researchers. Sorry. Okay. Next one, TNF alpha and interleukin 6. We know that TNF alpha and interleukin 6 are inflammatory markers. So mostly like once the inflammation comes, this is also can lead to inflammation. Sorry, it can also lead to infertility. So the inflammation we can see in the diabetic rats very high inflammation. When checking with the normal control, less inflammation we can see. When I give the plant extract like a TNF alpha and when interleukin 6 also, both of them significant distribution was decreased. So it indicates like this plant not only controlling the metabolic parameters, and also it is also useful for the reducing the like inflammation. So this plant also very useful for the improving the sexual sperm parameters, sperm count, motility, and viability also increase. I don't like to show all the results, just I want to show like some of the uh, morphologically abnormal sperms also decrease. Some abnormal sperms was decreased when I give this plant extract. So normal, I already told, like normal sperm have a hook shape. I check like a diabetic rat, so many abnormal sperms I can see from the diabetic rats. You can see here. Here, if you see that head also abnormal, tail also abnormal, and also here head is abnormal. Here we can see something like some like a hook, like a some hook, some of the like head also abnormal. Previously, I told HOS tail coil sperm, how it was like a tail was coiled like a look. The tail was coiled. This is called like HOS tail coil sperm. So from this figure, what can you understand? So normal, the sperm abnormality is very less in the normal control. However, diabetic rats, the abnormal sperm cell was very high. I give the extract, it was significantly decreased. So another techniques I like to show. This is like a DNA damage. So the hollow formation. Hollow formation means like a balloon-like structure. We can see here the like a balloon-like structure, like a hollow formation, like when the sperm DNA damage was observed. So we can see with the like how the DNA, whether the DNA damage or not. Once the DNA damage, previously we discussed, once the DNA damage, fortunately the DNA sperm damage sperm was maybe fertilized was happened. Progeny next generation was also abnormal sperms for the progeny also have some congenital abnormalities, so that whether whether is there any possible to reducing our plant extract or not. DNA damage we will check. When I check this plant extract, very significantly decreasing the DNA damage. Just I don't like to show all figures, just this indicate the DNA damage, the hollow like a balloon like structure, bulb like structure showing like a DNA damage. From this figure, other sperms are very nice, no effect. Some sperms only affect. Finally, when I give this plant extract, significantly decrease. Another technique, this one we called as a flow cytometry. So most of the people knows like flow cytometry. Here the green color indicate the normal sperm, the red one indicate the DNA damage. Generally the flow cytometry, so how it is work, the principle like a single DNA damage, single DNA, because the DNA once was damaged, double strand come to the single strand we will give the red color. So here when we can observe the diabetic rat, more red color is there, means DNA fragmentation index was very high. So nearly 86% diabetic rats. When I give the like this plant extract or diffuser, the DNA fragmentation index also decreased. So just my aim is I want to do like a different molecular mechanisms. Okay, coming for finally like other medicinal plant, because medicinal plant, what is the reason means this is like a it is also isolated from the one of the active compound from the Turnora diffuser. So it is a very huge. I hope finally I understand this plant have a very possible to reducing the infertility, and also they have a good uh, very good for the diabetes. So when I check for the some of the active compound mestic acid, one of the active compound. So when I go for the preliminary literature study, so I can see like a mestic acid also reducing like uh, a very useful for the diabetic people, and also it is also used reducing the oxidative stress. So I apply my plan on the diabetic rats. For this this model, just I want to when I go like a like I think everyone knows research is not a single day by day, like we need to go with like a different like a climate. So when I previously the type 1 type diabetes, when I induced with the like and nicotinamide, most of the reviewers they comment this is not accurate model. So then I'm looking for the accurate model. How the type 2 diabetes model is like accurate to the human beings when I check like literature. So I introduced another type of model. This is called like a so high fat diet. Generally, I give for 12 weeks. Once the rats are obese, once they become obese, I give low dose of streptozotocin. Once the streptozotocin was given, so what was happened? The pancreatic beta cells was damaged. Once the pancreatic beta cell was damaged, confirmed like a diabetes. Some rats are not into the diabetes, so we want to exclude from the study. So then I gave the stick acid for the 28 days. So fine, meantime, I check like a blood glucose levels, fasting blood glucose levels, and water intake also. So okay, now when I sacrifice the rats, I can see like a testis how the testis size also the testis size also decrease in the diabetic rat. So and also blood glucose levels like I would took like weekly once. Blood glucose levels diabetes very high. Whereas when I give the mestic acid, blood glucose levels was significantly decreased, and glucose intolerance we also decreased, and also ITT also we observe positive result. Okay, coming for the next one, I did like all like a basic from the basic parameters to molecular work. Coming to the sperm count, motility, viability also decreased in the diabetic rats. So when I see like a diabetic rats, the sperm count, motility, viability also decreased. When I give the muriatic acid, I significantly increase the sperm count and motility and viability. So morphology, mostly the diabetic rats very high. So I can observe so many abnormal sperm abnormalities. So I like to separate into the abnormalities like the head abnormalities, mid abnormalities, and tail abnormalities. On this picture, I think you can see everyone sees so many abnormal sperms. So mostly like a sperm abnormalities was observed when I give like a 28 days of the treatment. So this is one. Okay. When the sperm abnormality is very high, so means it indicates something like a DNA was damaged. From the picture, we can see the sperm DNA was damaged. From this picture, we can see the less sperm DNA are damaged. So when I give the matchstick as well, we can see this result. Okay. Coming for steroidogenic markers, is there any possibility to do like a steroidogenesis increase, decrease? So when I check this figure, from this figure, we can see like a double staining. From the figure, you can observe like a green color and red color. So the green color indicate the star protein. Previously, we told the star protein is one of the steroidogenic markers. The ARA54 also another steroidogenic marker. So it indicate the red color. So we can see from the normal control, so both of them very high. So mostly you can this is the leading cell. We don't want to focus on the other area because these proteins are expressed on the leading cells. When we check in the diabetic rats, it was significantly decreased. So the distribution was increased in the diabetic rat treated with the mestic acid. Coming to the B is another marker for CYP 11A1 also. Generally, we call it the 450 SSC. It is also another steroidogenic marker. So because the if you see the steroidogenesis, so many markers we can see. So I would like to do the all steroidogenic markers. Other protein is CYP19A1 also significantly decreased in the diabetic rats. When I give the mestic acid, it is also decreased. This figure shows the immunohistochemistry. This figure shows the immunofluorescent double staining. So I hope everyone can understand. So next one. Okay. Race. Race means advanced glycated product, also one of the complication problem in the diabetes. Once the hyperglycemia was increased in our body, advanced glycated end products were increased. So the race is a receptor advanced glycated end product. It is a marker for the advanced glycated end product. Once the hyperglycemia was increased, so mostly in our body the advanced glycated end products were increased. When I did like immunohistochemistry, we can see from the semen first tubule, the brown color indicate the expression levels of race. So in the race, in the diabetic rats, more expression ones we can see. So when I give like a pentextide, eventually it was significantly decreased, distribution was decreased. So coming for the NRF2 pathway, previously we told like in our body, in our body, like NRF2 and KEAP1 always associated each other with the cytosolic fraction. So once the stress was increased because of the oxidative stress, because of the rays, because of the hyperglycemia, any factors also make a dissociate NRF2 and KEAP1. Once dissociation was happen, NRF2 translocate into the nucleus, it will be it will activate the other antioxidant enzymes like SOD, catalase, GPX, NQO1, and HO1. So this aim is reduce the oxidative stress. So that is the reason we can see in the testis lipid peroxidation was increased when I give like a plant extract. This acetic acid, these things was decreased. So this one is like E is like SOD, catalase, and GPX. So we can see the antioxidant engines also increase the testis. Sorry. This C is indicate the like a double staining of NRF2 and KEAP1. So you can see clearly, you can see and a green color shows the NRF2, KEAP red color shows the KEAP. So here, so we cannot tell like it is only present on the leading cells. It will because it is not like a steroidogenic marker. So whole body, whole cells have this these proteins, so that we can see the whole is green and red color. So when this is the protein distribution of NRF2 and KEAP1. Okay, next one, inflammation. So previously we discussed. So once the oxidative stress was increased, NFKB and IKKB will be dissociated. Once the dissociation was happened, NFKB translocated in the nucleus. It will be trigger the other inflammatory marker. Just you remember the previously NFKB once the trigger, it like to decrease the oxidative stress. But NFKB once the trigger, it will be stimulate the other inflammatory marker. So our aim is need to reduce the dissociation of the NFKB and IKKB. Once the dissociation was decreased, so it cannot move to the it cannot translocate into the nucleus. Once it cannot translocate the nucleus, so other inflammatory markers like a TNF alpha, interleukin 1b, interleukin 6 cannot produce. Once the can produce, the inflammation was decreased. That is our aim or motto. So if you see our my mRNA levels of like NFKB and TNF alpha and also interleukin 1 INOS, so significantly higher in the diabetic rats, whereas in methyltic acid treated rats, it was significantly decreased. This is the protein Western blot result. So protein expression was very high. So when I give like a methyltic acid, it was significantly decreased. C indicate the double staining of NFKB and interleukin 1b. We can see like a less color green and red color. But however, in the less green and red color indicate the more inflammation in the testis of the diabetic rats. Eventually, when I give the medicinal plant, medicinal active compound methyltic acid, it was significantly decreased. And B indicate this figure shows the immunohistochemistry. It shows the like a TNF alpha, and also it shows like interleukin 1b. So we can see here the diabetic rats more inflammation. When I give the medicinal plant or methyltic acid, it was significantly decreased. Okay, final pathway is apoptosis. We know this apoptosis, once the inflammation and oxidative stress was increased and apoptosis was increased. Once the apoptosis was increased, coming to the mostly the sperm DNA will happen. So we can from the picture we can see the Western blot result. BAX was increased and BCL2 was decreased. I think everyone knows BCL2 is anti-apoptic marker. So caspase was increased. So from the figures, diabetic rats have more BAX plus BCL2 and more caspase 9. When we give like a methyltic acid, it was significantly opposite one. What opposite was happen? So coming for the figure B, it shows the BAX distribution. So we can see here the seminiferous tubule more BAX protein expression levels. When I give like a methyltic acid, it was significantly decreased. So sorry, maybe some people have a boring. Maybe I want to show like a different how we can do like our research on the more molecular work. Okay. Finally, you can see here the D figure shows the PCNA. Mostly PCNA is a proliferation marker, so it is expressed on the nucleus. From the figure, you can see like mostly we can see like a dot figure, so it indicate the nucleus, so the spermatogonia cells. So we can see here PCNA. Less PCNA was observed in the in diabetic rats, whereas mastitic acid treated rat it was significantly increased. So finally, I also did gap junction proteins also like acridin and also cadherin. You can see here from the figure gap junction protein. The gap junction proteins are very high in nicely the seminiferous tubule nicely attached to each other with the gap junction protein. When the diabetic rat, it was significantly decreased. We did not see like a gap junction protein. I think everyone can see like very nice green color, but we can see less green and green color. It indicates the gap junction protein was disturbed. When I give like a medicinal plant, it was significantly increased. So these are the gap junction or tight gap junction protein. Okay. So finally, I would like to conclude from the by using the medicinal plant. Like I did only few medicinal plant and bioactive compounds. So I did on some of the medicinal plant on female reproductive system also, female reproductive complication also. Finally, I would like to conclude when I give the medicinal plant, so it will decrease the oxidative stress, and the oxidative stress was decreased. Antioxidant engines, sorry, it was opposite way. Antioxidant engines were increased. So sorry, here, okay. Antioxidant engines were increased. Once the antioxidant engines were increased, so it protecting this. Once the sperm was protecting, what was happening? The sperm count, motility, viability, and HOS 12 coil sperms also increasing, and also decrease the sperm abnormalities. Also, it decrease the sperm DNA damage. Next one. So by using this medicinal plant, what was happening? It was decrease the dissociation of NFKB and IKKB. Once the dissociation was decreased, so the TNF alpha cannot translocate into the nucleus. Once the translocation was inhibited, so less production of the TNF alpha, interleukin 1B, interleukin 6, other inflammatory markers. Finally, I would like to conclude my future research mostly like I want to screen some of the medicinal plants. So both they have like anti-diabetic properties and also both like a infertility. The reason whatever available drugs are available in the market, whether they are anti-diabetic drug, whether they are infertility drugs. So mostly less drugs are available, no drugs, less drugs are available in the market. So both can reduce my aim is they must be reduced the hyperglycemia, they must be reduced the infertility problem. So mostly I would like to screening some medicinal plant. I would like to isolate some of the active compounds. So this is my future direction or future goal. So I would like to conclude. So why I did like a natural product. So natural products or medicinal plants are very less toxic when compared to the synthetic drugs. Even though WHO also recommended, so the worldwide so many hyperglycemic agents are needed. So whatever we have like some drugs are available in the market, not enough. We need to find out the new medicinal medicines are we need to find out. So the WHO also recommended. So finally, I would like to conclude. So alternative medicines are very, very important. It is very, very challenging, only not only for physician, it is also challenging for the researchers. Because why it is very challenging? So the world population is increasing, so many complications also increasing. So that we need to find out more drugs, more medicines to the natural product. This is one of the challenge for the young researchers and also medical doctors also. Thank you, friends. If you have any future doubts, just email me. Like this is my email address. So thank you for listening and also spending your valuable time. So thank you, everyone. If you have any doubts, maybe just we will discuss.
Hello, sir.
Tell me, sir.
So any specific genes involve DNA damage for fertility?
Specific genes.
Gene for fertility?
Can you, what is the question, sir? Any specific genes?
So any specific genes involve fertility?
Sperm DNA damage.
Yeah.
Okay.
Genes.
if you go deeply, sir, so many genes are available, but basically, if at all frankly, I did not deal like a gene level, sir. Just I like to work on whether the DNA damage or not. I'm frankly telling I did not do for the what genes are damaging sperm DNA damage, because I feel like once the stress was increased, like a damage was happened. So good idea. Maybe in future I would like to continue like any genes. Okay, thank you, sir.
Oh, thanks, sir. Another one question, sir.
Tell
So
me, sir.
the plant drugs control the diabetic 2 and also diabetic 1 also?
No, sir. Whatever I did, what, sir? What you said?
Sir, the plant drug control diabetic 1 or 2?
No, sir. Just I did only type 2 diabetes only, sir. Sir, I did not do any type 1 diabetes.
Okay, sir. Thank you.
Because if the type 1 diabetes, like some people, they said type 1 diabetes, pancreatic beta cells totally damaged. So means like when I give the streptozotocin, they have a chances. But my aim is world population is mostly affected by the type 2 diabetes. So this plant extract, what I did like a medicinal plant all on type 2 diabetes, sir.
Okay, sir. Thank you, sir.
Thank you, sir. Thank you so much, sir.
Thank you.
Any question for audience? Hello? Dear participants, would you like to want to vote of thanks to Nelly Kribabu means please do the vote of thanks. Anybody want? Hello? Anybody want to do the vote of thanks means mute yourself. The please stop.
I think everyone may be mute, maybe that's why I cannot talk.
Unmute all. Agree? Doctor?
What, sir? I need to
Unmute.
unmute.
Unmute all. Unmute all.
How to unmute? Huh?
Just click the participant. Unmute.
Unmute. Okay, I think unmute or mute. Can you take like a sir, can I give like a host to you?
Yeah, you can change the host.
Okay. Can you give me 1 minute?
Just click near my name, then you will see the mute and the more option. Then change the mute.
More. So okay, make a host. Okay. Okay. Then
Yeah,
okay. Okay. So make a unmute for other people, sir. I don't know how to make it.
Okay, thank you. Thank you, Dr. Gribabu, for your excellent informative presentation about the male infertility. Now we learned a lot of things from your research work. I think this is your all of the research work. You presented it very well, and also the oxidative stress is one of the most important for the damage the DNA stress. We learned medicinal plant extract is useful for the increase the infertility, reduce the increase the sperm activity. So the medicinal plant like Coccinia, Mangostina, and the Ternera species, these lot of medicine, these extract very useful for the diabetic person also. So thank you so much for once again. I would like to thank all you, all the participants from various university institution watching this seminar. Thank you giving the opportunity for our Honorable Vice Chancellor, Periyar University, and the Registrar of Periyar University. Thank you, Dr. Giri Babu, for accepting my invitation. My invitation. Thank you, Doctor. Thank you, Doctor. You unmute yourself. Click.
Okay, someone asking maybe want to question like Shruti Tripathi. Maybe someone raising hand. Maybe they asking any doubt. Hello. Okay. Okay, friends. Thank you for listening. Thank you. Okay, Dr. Kumaran, I think maybe make unmute.
Okay, no problem. We can leave the meeting, end the meeting.
I can see Dr. Professor Vijay Pandey also. Okay, thank you.
Yeah, he's online. Vijay Pandey also is there, right?
Okay. Thank you, sir. Thank you. Okay, I can leave.
Okay, can leave. Okay.